Hello WS Matrix on YouTube. Let's talk about an intriguing topic today, diving into the world of language models, specifically the multi-billion parameter language models called Megatron-LM. By the end of our discussion, you'll have a handle on this cutting-edge technology, so stick around. Now, you might be asking, what's Megatron-LM and why should I care? Well, in the realm of language models, bigger is often better. Larger models can understand and generate more nuanced, accurate language. The challenge, though, is how do we effectively train these behemoth models? That's where Megatron-LM comes in. Megatron-LM is a method to train large language models, and it utilizes something known as model parallelism. But before we go further, let's take a step back and understand what parallelism in deep learning means. In a typical deep learning scenario, you train your model on a single device, say, a GPU. But as models get larger and more complex, this might not be enough. So we use multiple devices in parallel to speed up the process. Now, there are two main ways of doing this: data parallelism and model parallelism. Data parallelism is straightforward. It's like dividing a pizza among friends. You divide your data into smaller parts and train them on different devices. Each device gets a complete model but works on a different piece of data. Model parallelism, on the other hand, is like building a car on an assembly line. Each device gets a different part of the model and works on the entire dataset. So, instead of each GPU getting a whole model, they each get a piece of the model to train. Now that we've got that down, let's talk about why Megatron-LM is a big deal. You see, training a billion-parameter language model isn't a walk in the park. It's like trying to build the world's largest jigsaw puzzle. You need an efficient way to split the model across multiple GPU, ensure they communicate effectively, and bring it all together. And that's what Megatron-LM does. Megatron-LM leverages model parallelism to train these massive models. It splits the model across multiple GPU, where each GPU is responsible for a part of the model. But there's a secret sauce to how it does this. It uses a technique called tensor slicing, which is a fancy way of saying it divides the model's parameters, the tensors, into smaller parts, and each GPU gets a slice. But how does it decide which GPU gets which slice? Well, it uses something called 2D tensor slicing. In this method, the model's parameters are organized into a 2D grid, and each GPU gets a cell from this grid. This approach helps balance the load across all GPU and ensures they're all working efficiently. Now that we understand how Megatron-LM slices and dices the model using tensor slicing, we should understand how these GPU work together to train the model. It's not just about slicing the model into parts, it's also about how these parts interact and learn together. Megatron-LM uses a combination of model parallelism and data parallelism. Remember the pizza and the car assembly line? Well, imagine having multiple assembly lines, model parallelism, and each line is also sharing pizzas, data parallelism. It's the best of both worlds. In this setting, each GPU gets a slice of the model, and it also gets a slice of the data. Each GPU processes its data slice using its model slice. Once it's done, it needs to share its findings with the other GPU. This sharing is crucial because each GPU is only seeing a part of the model and the data. To get a complete picture, they need to pool their knowledge. This pooling of knowledge happens through a process called all-reduce. In simple terms, it's like a group discussion. Each GPU shares its results, they all combine this information, and each one gets the combined result. This way, all GPUs stay updated with the overall progress of the training. It's a bit like each slice of the model getting a chance to learn from the experiences of all the other slices. But there's another crucial aspect we need to consider: the sequence in which the GPU process their slices. Since each GPU is handling a different part of the model, the order in which they do their work matters. If they all worked simultaneously, they might need information from each other that isn't ready yet. It's like trying to put the roof on a house before the walls are up. To avoid this, Megatron-LM uses a specific sequence called a pipeline parallel schedule. It's like an instruction manual for the GPU, telling them the order in which to process their slices. This way, each GPU knows when to work and when to wait for information from the others. Now that we've understood how Megatron-LM uses model and data parallelism and ensures all GPU work in harmony, it's important to know that there's another critical aspect we need to talk about: memory management. As you can imagine, training a billion-parameter model is not just computationally intensive, but it also needs a lot of memory. Each parameter in the model requires memory, and when you have billions of them, that adds up quickly. But GPU have a limited amount of memory, so how does Megatron-LM handle this? Well, Megatron-LM has a few tricks up its sleeve. The first one is something called activation checkpointing. Remember, during the forward pass, each layer of the model computes its activations and passes them to the next layer. These activations need to be stored because they are used again during the backward pass when computing gradients. But storing all these activations for a billion-parameter model would be memory-intensive. To save memory, Megatron-LM uses skip activation checkpointing. Instead of storing all the activations, it only stores a few and recomputes the others when needed during the backward pass. It's a bit like not writing down every step of a math problem, but remembering enough so you can quickly redo the steps if needed. This way, it significantly reduces the memory footprint. Another memory-saving technique it uses is offloading. Sometimes, even with activation checkpointing, the model might be too large to fit into GPU memory. In such cases, Megatron-LM can offload some of the model parameters to CPU memory, which is slower but more abundant than GPU memory. It's like keeping less frequently used tools in a separate toolbox, fetching them only when needed. So, we're dealing with a massive language model, one with billions of parameters. We've sliced it into manageable parts using tensor slicing and distributed it across multiple GPU. We've got these GPU working in harmony, sharing their findings, and following a specific sequence to avoid chaos. We've also managed to squeeze this gigantic model into the limited memory of our GPU using activation checkpointing and offloading. But what does all of this achieve? Well, by enabling us to train such gigantic models, Megatron-LM paved the way for unprecedented advancements in natural language processing. They realized that these models can generate text that is incredibly fluent and coherent over long passages. They can answer questions, write essays, summarize text, and even generate Python code. The potential applications they realized at the time, back in 2020, were wide-ranging, from drafting emails and writing articles to customer service and language translation. But more than just the applications, Megatron-LM also pushed the boundaries of what's possible in AI research back in the year 2020. It demonstrates how we can overcome the limitations of hardware and keep scaling up our models. It provided a blueprint for future research into large-scale model training, paving the way for even more advanced AI models. Finally, it's important to remember that while Megatron-LM is a significant advancement, it's not the end-all solution. Training these models is still a resource-intensive task, requiring a lot of time, computational power, and energy. Moreover, these models need massive amounts of data, raising concerns about privacy and data security. So, while we marvel at the capabilities of techniques like Megatron-LM, we must also continue to strive for more efficient, secure, and ethical AI solutions. And that, dear friends, wraps up our deep dive into Megatron-LM. We've journeyed through the intricacies of training multi-billion parameter language models and touched on the broader implications of this technology. I hope you found this exploration enlightening. Remember, the world of AI is vast and ever-evolving. So don't forget to hit that subscribe button and leave a comment to stay updated on all things AI. We have a variety of videos on AI that may interest you, so feel free to browse through our channel for your entertainment. Keep exploring, keep learning, and stay curious.